Here is an equation sheet with all the equations you need to know. Though you certainly don't need to memorize them all, it does help to have a general understanding of each of them. The equations for speed and the equations for acceleration are quite obvious, so I'll just begin by going over a velocity time graph. You're going to need to be able to find the acceleration and the distance travelled. Beginning with the acceleration is simply the rate of change of velocity, which is going to be the rate of change of the graph itself. So you do this by finding the change in velocity there, and then you find the change in time, and you divide the change in velocity by the change in time. So in this example, 25 divided by 200. Next, to work out the distance, you need to know that velocity times time is equals distance. So what you do is you find the change in time, and you find the change in velocity over an interval. In this example, the change in velocity is 25, and the change in time is 200. Now, you'll notice that this isn't going to be 200 times 25, because we're dealing with a triangle here, and we need to find the area under the graph. So what it's going to be instead is 25 over 2 multiplied by 200. So, doing the math for this one, we get that it's equal to 2,500 meters, and that's the distance travelled between point A and point B. The technical reason you divide by 2 is because you're taking the average velocity over that period. So the velocity at one point was 0 and the velocity at one point was 25. So essentially you're multiplying the velocity of 12.5. For this next question we need to look at good old F equals ma. So let me just write that down. I feel like Khan Academy right now. F equals ma. So essentially what this is saying is force equals mass times acceleration, and the mass of this guy is 80 kg. Now because the acceleration of gravity itself is going to be 10 meters a second, his weight going downwards is 800. So let me just write that down. So acceleration is 10, mass is 80, and then the force, the resultant force here, well not the resultant force, but the force of gravity, is going to be 800. And you may notice that this is just another form of the equation of weight equals mass times gravity. It's the same thing. Now, the question here is asking us is what is the acceleration of the skydiver based on the resultant force? So here we need to calculate the resultant force, which is the overall force on the guy. So because of air resistance, we have 200 newtons of force going upwards. That's from the air molecules hitting him, forcing him upwards, and 800 downwards. So all we have to do is 800 minus 200, and that of course equals 600. So this is the resultant force acting on the guy, 600 newtons downwards. Now, if we use F equals ma right here. We know the guy's mass is 80. We know 600 is going to equal to 80 times A. Now just to get A, we do 600 over 80. And that's going to equal something, so it'll be like 7.5 perhaps, 7.5 I reckon. Yeah, so 7.5 meters a second squared. And that's going to be the acceleration of this guy going downwards. So that's how you use F equals ma, and that's how you use W equals mg. The next equation I'm going to explain is work done equals force times distance. So work done is essentially the energy transferred to something, or the energy you need to displace something a certain amount. Now, let's imagine the example of a box. And there's this little man, and he keeps trying to push this box, right? And he's pushing with a force of, let's say, 300 newtons. So in this direction, 300 newtons. And by applying this force to the box, he moves the box 2 meters. Now, based on this equation right here, we have 300 newtons, which is the force, and we have 2 meters, it's the distance. So that means this guy has transferred 600 joules of energy to the box, which basically means he's given energy to the box in the form of kinetic energy by moving it, and the box, by means of friction and heat, has lost this energy as it's moved, and it's come to a stop. The formula for kinetic energy and the formula for potential energy are perhaps the most important equations you'll see in the exam. So beginning with the equation for kinetic energy, we have that's equal to 1/2 of mv squared. But what does this mean? So let's take an example to begin with. Let's say I have a gun, and I fire from it with a bullet. Now, this bullet will have velocity, and it will have mass. As a result of that, it will have kinetic energy. So in the exam, you'll most likely be asked to calculate the kinetic energy the bullet has, based on knowing its velocity and its mass. So you might have to work out one of these properties for yourself, based on other information. So let's say the mass of this bullet is 5 kg. I have no clue how much a bullet weighs, but let's say 5 kg. And then it's moving at 100 meters a second. So, as you can see, velocity is squared, which means the variability in velocity is more proportional to the kinetic energy than the variability in the mass. So the velocity matters more, basically. So right here we do 1/2 multiplied by 5 multiplied by 100 squared. So 100 squared, that's going to be 10,000. Times 5 times 1/2, which is equal to 25,000. That's going to be in joules. So this is the amount of kinetic energy the bullet possesses. Looking at the equation for potential energy now. This is energy you have as a result of your location relative to a gravitational force. Let's say we're talking about the gravitational force of the Earth, which almost always is what you'll be talking about. So this is going to be the Earth, and there's going to be this, well, this isn't the scale, this would be an enormous tree, but there's this tree, and this little dude starts standing here, and he climbs up to here. It's an awful drawing, but let's say he climbs 10 meters. Now, and the man weighs 80 kilograms. Oops, okay, 80 kg. Now you're going to have to know what the gravitational acceleration of the Earth is to begin with. That's kind of a given. So that's going to be 10 meters a second. Now, h in this equation represents the increase in height, so that would be the 10 meters. G is going to be 10 here, and m is going to be 80. So we end up with 80 mass times 10, the acceleration, times 10 again, the height. Don't know if I subconsciously did that. Then we have 100 times 80, which equals 8,000. Does it? Yes. Okay. So, 8,000 joules of energy is gained because of his movement there. On the right here you can see my attempted diagram of a spring falling down the stairs. And on the left we have two equations which describe spring motion. So in spring motion you have force, the spring constant, and the displacement of the spring itself. This is the first equation. So to visualize this, let's take a spring like this, and then we attach it to a hook. And let's say this hook's on a stand like so. Now, when you apply a force F, say pulling downwards on the string like this, ignore the terrible arrow, then that is going to stretch the spring and displace it. Now the displacement, or the amount that the spring stretches, is x. And what k essentially represents is the stiffness of the spring. It's called the spring constant. So you'll notice if k is higher, then a higher force will have to be applied to get x to be bigger. You can rearrange this to sit like this. F over k equals x, right? So the bigger k is, the smaller it makes x, right? So the spring constant is the stiffness of the spring. So you might have a question asking, how far is a spring displaced when a force of 100 newtons and a spring constant of 5 is there? So if we take F equals kx And then we have, what's it, 100 newtons, 100 over 5 equals 20. And now, depending on the units, this probably be meters, but it depends on the context of the question. So remember to read that. So in this next equation, work done equals 1/2 of force times displacement. Now we can visualize this in a graph, like this. And we have a proportional relationship here. So on one axis we'll have force, and on the other we'll have displacement. How am I going to write this like that? Displacement. It's terrible handwriting, but never mind. So, to get the work done, we're calculating the area underneath this graph. Now you've already seen this before with calculating the distance from a velocity time graph. And this is essentially the same thing. So you imagine it like a triangle. And that's why you have this 1/2 in the equation. So say the force here goes up to 10, and the displacement goes up to 5. Then you do 10 times 5, and that'll give you the area of this whole thing as if it was a box. And then what you're basically doing is multiplying by half to get just this. And that'll give you the work done. So just solve that quickly. 1/2 times 10 times 5 equals 25. There we go. P equals mv, or momentum equals mass times velocity. Now momentum is a measurement of the state of motion of an object. This is often confused with inertia, which is a measurement of the tendency of an object to remain in its state of motion. Now this can be very confusing, and you don't really need to know the difference, you just need to know how to do the equation. Now, let's say we have a bullet. So let me just draw that. So we have a bullet, and let's say we have just a huge ship. Now this huge ship has a massive mass, but it moves very, very, very slowly. And then this bullet, hold on, let me reach out this bullet. Alright, this bullet has a very low mass, but a very high velocity. Now, because of this equation, they will have similar momentum. Now, inertia would simply be, say, a rock. The resistance of that rock to being moved. Now, inertia is simply a product of mass. In fact, inertia is measured in mass, which means it's a scalar quantity. It only has one property or parameter in the equation. Whereas momentum is what you call a vector. It has mass and velocity. So, just to illustrate the equation here, let's say this massive ship has a mass of 10,000 kilograms. And it's moving at 5 meters a second as it goes along. Now, you calculate the momentum of this by multiplying them, so that would end up being 50,000. And the unit for momentum is kilograms meters a second. If this video did help you anyway, I'd greatly appreciate it if you liked it and subscribed, and give me any video suggestions, because I'm out of ideas.